front of you, okay? And I want you to pack it with cubes. And we're not taping them, we'll just do the best we can. While you're packing it with cubes, I'm going to pause it. So before we solve this problem, I want to talk about the figure you just built with your cubes, okay? So this is the base, correct? So there are 4 along the bottom, right? And how many layers high is your figure? 2 layers. And those 2 layers are actually right here, aren't they? Okay, go ahead and label the height. Now, the length and the width are inside of the area of the base. So, and that's 4, right? So we've got, look at this, 2 by 2. And you can't see it very well. My blue isn't showing up very well. Right over it with black. That's a little better, isn't it? Okay, so if I were to write a multiplication sentence for this length times width times height, what would I write?
2 times 2.
Let's put it on this line, even though it's not going to fit. We'll just keep writing. Is this correct without the centimeter labels?
No.
No. How many total cubes were there?
3, 4.
8. There were 4 on the base, and then 4 on top of that, okay? So I wanted to remind you how to write the formula for length times width times height, okay? Let's go down. I want you to go ahead and fill figure B from yesterday, and then we'll write a multiplication sentence for that one. Okay, so let's take a look at the second figure. And I'm going to switch to black again so we can see it. So the length is what?
2.
Oh, it didn't switch me. Hold on. It's 2 centimeters. And then the width is 4 centimeters. And then the height is 2 centimeters. So what will my multiplication sentence look like for this one?
4 centimeters times 2 centimeters.
Okay. I really like the way you are including the labels when you tell me. It doesn't really matter what order we put them in, but I did length times width times height, okay? It doesn't matter though, because it's multiplication. You can switch it around. Commutative property. What was the total of this?
16 centimeters.
Cubed. Everybody say it. Cubed.
16.
Okay, please take your hands off the cubes. All right? I don't really want to build this one. We're not going to have time anyway. Because the lesson is so fun once we get moving on. Okay? So, what I want you to do on this one is help me label it on your paper. Okay? So, the length is what? 4 centimeters. Everybody write it. The width is 4 centimeters. And the height is, okay. Now, I'm going to go ahead and write 4 times 4 times 3. But watch where I'm going to put my parentheses.
The 3 and the 4 is going to be...
Why did I want my parentheses there?
It's easier to...
Multiply. Do I know 12 times 4 in my head?
Yeah.
And I don't know 16 times 3, except I do now. Because it's the same thing as 12 times 4, isn't it? So that gives me what?
48 centimeters cubed.
Very good. Okay? And that's length times width times height. But I can put my parentheses wherever I want. Okay, please take your hands off of the shapes and the cubes for a minute. Let's go down to this one. Now, we've got a little bit of predicting we're going to do. The thing with the predicting is the kids are all getting their predictions right today. So you're very good at this, okay? But I don't want you to build it. I just want you to look at it, okay? And you can look at this as length times width times height, okay? And I want you to come up with a number of how many cubic centimeters you think it is, and I'm going to pull a stick. Are you okay with me pulling a stick? Yeah. I don't think anybody's going to get it. So, Caden, how many do you think this is?
8.
8. 8 cubic centimeters. Everybody write it down. And it says, briefly explain how you came up with that 8. So in your mind, Caden, how did you count these?
I did 4 times 2 times 1.
Well, you did? Because I just looked at it and I looked at it and I saw 4 cubes.
Yeah, and then on the back there's 4.
So 4 in front, right?
Yep, 4 in front and 4 in back.
And 4 in back. Is that how you looked at it? Whoops. In back. Is that how you looked at it to start with, Caden?
Yeah.
Yeah, me too. Okay? And
you
that's
write
not
that?
even a complete sentence. I'm just briefly explaining how I counted them. Go ahead and briefly explain how you counted them, okay? All right? Now, I want you to build it with your actual centimeter cubes. Build this figure. And I'm going to pause it while you build it. So now that you have that figure created, what multiplication sentence could I write for the volume of the figure? Oh, I think I'll pull a stick. So, Brendan, I pulled your stick. What multiplication sentence could I write?
4 times 2.
How tall is it?
1.
Good.
We need the other structures.
And, no, you don't have to keep the other structures. There's my volume. Can you please write that multiplication sentence? Okay? All right, we're going to do 2 more like this. They're on the back. So let's turn to the back and then we'll get to the fun part. Make a prediction, briefly explain how you came up with it, then build it and check it. Okay? All right, so I'm going to pull the stick for the prediction. You guys ready? Did you turn your page? Okay, Alex, what's your prediction for this shape? B.
16.
I think you're right.
Mm-hmm.
Now, how did you come up with that? Let's briefly explain it.
So, like, I didn't have time to count them all, so I just multiplied 4 times 4.
Okay, so you looked at 4 here and you knew it was doubled. So 4 doubled. Anybody do it a different way?
I did 8 plus 8.
I did 8 plus 8 too. I saw 8 in the front and 8 in the back. Okay?
You clearly know it's going to be 8 if there's
8 plus 8. Okay. All right. So now I want you to build it and then get ready to length times width times height. Okay? Right. I'm going to pause it while you build. Okay.
It doesn't like me.
So I'm going to pull a stick. Brianna, can you help me with a multiplication sentence for length times width times height? So how far across is it?
4
4 what?
times 2. 4 centimeters.
4 centimeters times 2 centimeters times, how tall is it?
2.
2 centimeters. And that gives me, do we want our parentheses here? 8 times 2 is 16 cubic centimeters. Okay? If you don't put the 3, like I forgot the 3 a minute ago, then it's not going to be correct. Okay? Let's do a prediction on the next one. I'm going to pull a stick. Brandon, what do you think this one is?
I know. 40?
So, Brandon, how did you come up with 40?
I counted the front and the double.
Okay, so you doubled the front. I like the word doubled. Can you go ahead and build this?
I did something different.
What did you do?
I times 8.
So you did 5 times 8? Why'd you come up with 8? Because this is just 4.
Because
you doubled the 4. So here's what Caden did. He did 5 times 4 doubled. Okay, go ahead and build it. So right now, what's the length?
4.
1, 2, 3, 4, 5 is what I've got. Okay, and what's the width?
4.
How far does it go back, the depth?
2.
2. And how tall is it? Can you label your shape, please?
4.
Okay. So, Andres, give me a multiplication sentence. Give me a multiplication sentence for length times width times height.
5 times.
Do you want to put 2 next?
4.
Okay.
But you read my book 5 times.
I read your mind. So you want to do 5 times 4 first, and then times 2. Good. You guys agree? And I can write it however I want.
Yeah,
Okay, so that's the end of that part. Here's what I need you to do. Promise me not to touch your cubes. Just slide them away from you, okay? We're going to go on to the next section. So you've got a figure in front of you that's called a net. Everybody circle the word net for me, okay? And here in a minute, you're going to cut out your net and you're going to work with it. But before we do that, I want to talk about the net. So the net is actually a figure that's flat, that's going to be folded into a 3-dimensional shape. How many of you have ever made a cube before? So you already know this is going to fold into a cube, don't you? But do you know that you're going to have questions about this on your math test? Not everybody knows that. Because you know how your math test keeps leveling up every time you get a question right? Okay? Well, some of you haven't got enough questions right to get to these, but you will now. When you take it the last time, pretty much everybody's going to see the nets on there. And the question's going to be kind of like, which one of these will fold into the shape of a cube? Okay?
This one.
And what's really interesting about it is the cube is a rectangular prism, isn't it? We studied rectangular prisms. Please get your hands off your cubes. So we've got a base, and then we've got each level that's the same shape and size as the base, correct? And it folds into a cube. And I just happen to have a net here. This is the net that you have in front of you. Mine's just plastic, okay? And if I fold this, it will make a cube. Are you with me? Mm-hmm. So I want you to look at the net, and we're going to talk about the shape of it. So how many sides does a square have?
6.
Not a cube, a square.
4.
4. So look at this. 1, 2, 3, 4. These are the sides of my cube. Okay? Then I've got the base and the top. That equals 6, like 6 numbers on a die. Okay? Now the thing about this net is I could move the top and the base to different places, and as long as I have the 4 in a row, it's going to work. I'm going to show you on the board, and I hope this will come out on the video. But I could take this one, maybe, and put it down here.
Oh, no.
And it will still work.
Yeah.
Okay? And I want you to visualize it with me. Okay? So if I take this one and I put it down here, okay? Okay, remember these are the sides, so I'm going to fold it. Okay? And this one was actually on the last one. Could I have it hanging down here and fold it in?
Oh yeah.
Yeah, I could. And could I have this hanging over here and fold it in? Yeah. So, here's what you need to know. For a rectangular prism, because that's really what a cube is, okay? For a rectangular prism, you need 4 in the middle, 1 on each side, and it doesn't matter where they are. It can have 1 up and 1 down. It could be any way. If you have 2 on this side and none over here, that won't work, okay? So this is the cube, but it's also a rectangular prism because a square is really a rectangle. Does a square have 2 opposite sides that are equal?
Yes.
Are they parallel? Yes. And does a square have 4 right angles?
Yes.
Then it's a rectangle, okay? So the next shape I want to show you is another rectangular prism. I'm dropping things. Actually, I'm getting out of order here. Here's another cube. Do you think it's going to work?
Yes. Yes.
Those are the sides, the top, and the bottom, or the base, okay? But remember, these were in different places, okay? This is a rectangular prism as well, but it looks like rectangles, doesn't it? Okay? So the sides, the top, and the bottom. Are you with me?
Yes.
Okay, now I've got another rectangular prism. Rectangles again. These kind of look like squares, don't they? I don't think they are, though. Okay? So does that prove that as long as they're on opposite sides, the top and the base, it will still work, okay? All right. So now, this is fun. You want to do some other shapes just for the fun of it?
Yes.
Okay. So let's do this one right here. What do you think? This
Triangle. Pyramid.
It's not, well,
It's a pyramid.
he thinks it's a pyramid.
It's a
Let's see.
It's not a pyramid. It's a sphere. It's a canopy. Oh, whoa.
What do you think that's called? Okay, be serious though. Give me a mathematical term. I know it's a prism. You know how I know? Because the top and the base.
Triangular prism.
Triangular prism. The top and the base are the same, aren't they?
Triangle.
Okay, now look at this. How many sides does a triangle have?
3.
There you have it. Pretty cool, isn't it? Okay, the other triangular prism. Is right here.
Yes.
No.
That's a pyramid.
Yeah, that's a pyramid. Triangular. Here it is. 3 sides, right? The top and the base. Triangular prism. All right. Now I've got another prism. Really cool.
Oh,
Remember the top and the base are the same, then it's a prism.
Hexaprism.
Hexagonal. I had to look it up. Hexagonal prism. Okay? Just a minute. Now you see how the hexagons, how many sides are on that? My goodness, you're good. See how they're not in the same place? Do they even have to be right across from each other? No, they don't, because we just did that on the board. So this is a hexagonal prism. Okay? Prism is different than pyramid. Pyramid does not have the top and bottom that are the same shape. The pyramid goes to a point. What kind of pyramid is this? Look at the base. Triangular pyramid. Okay? What kind of pyramid is this? Look at the base. Rectangular pyramid. You guys are good. Okay? Now, I've got another triangular pyramid. And this is a rectangular pyramid. Look at the base. It's a rectangle or square. Look at the base. Look at the difference in how these two are shaped.
The rectangular is more bigger at the bottom.
And they're both going to be the same thing, aren't they? Okay, just a minute. Just a minute. Remember, I'm recording and I want to finish this real quick. Okay, I've got some more fun ones. Let's see, that goes there. Oh, you learned this in kindergarten. What's that called? It's a cone. It's a cone. Looks like a person. Okay. You learned this in kindergarten. What's this one? Cylinder. Okay. Okay, now listen. So right now, boys and girls, what I want you to do is I want you to cut out your net and fold it up. And do it as quick as possible, please. Okay, so what I want you to do now is you've got it folded. Look and maybe fold the top back so you can see inside of it. And I want you to make a prediction as to how many cubes it will take to fill it. And then I need a volunteer to raise their hand and give me their prediction. Bella.
I think 16.
She thinks 16. So what do you think the base is going to be? 4? Okay. All right. What do you think, Eduardo?
It's all going to be 4 because it's
So you think it's going to be 4, 4, 4, 4, make 16? Okay. Anybody different than 16? Jackson, what do you think?
I think it's going to be like 20 maybe.
20? Okay. 8.
Yeah, 8.
Okay. So I'll tell you what. I'm going to write those predictions down. So we had an 8. Whoops, I'm still on black. We had an 8, right? We had a 16, and we had a 20, right? Better get my cubed on there. Now what I want you to do is fill it, and we'll see if you were right. Okay, what was the base? 9. Anybody want to change their prediction?
27.
You think it's going to be 27. Anybody agree with Bella? Think it's going to be 3 high? All right. That's a pretty good prediction,
Yes.
Bella. All right. So let's see what we got. Oh. Now, our thought process as we made our prediction, did we look at the base and then figured out how tall it was going to be?
Yeah.
So we took the base times the height, didn't we?
Yeah.
We did. That was our thought process. So what was the actual answer?
27.
27. What multiplication problem can I use to represent that volume?
9 times.
It's not 9, is it?
Yes. 9's the base.
9's. It's not 9 though.
3.
3.
3 times 3 times.
Okay, so 3 times 3 times 3 equals 27 cubic centimeters. And this is where we got the 9. The base was 9, right? So is this length times width times height? And length times width is actually, what's that called? Area. Don't forget. Sometimes you can do the area of the base times the height. All right, so let's look at the exit ticket. Everybody turn and look to it. I went ahead and wrote a few things down for you, just to kind of help you, okay? And I went ahead and wrote these in blue so you could see them. So you're going to make a prediction about how many cubes you think this is on the second one. On the first one, you're just going to visualize it, fold it up, and write a multiplication sentence. Is it okay to build these to make sure you get them right? Of course it is. Okay? Do you know what you need to do? Now, I'm going to tell you one more thing. Are you ready? Don't forget this important stuff. What is it?
CM.
Right. And then, yes. Okay, so be careful. Don't rush through this and get it wrong just because you forgot your labels. If you forget your label, you're only half right. Okay?